It's going to be a short video on creating forensic test images, just my thoughts, some suggestions, and recommendations. First thing I want to talk about is considerations with third-party images. And this is third-party meaning images that you did not create yourself, that someone else created. Now, on the DFIR.training website, there's terabytes of images, test images, and they're all third-party. And there's subcategories such as CTF, challenges, capture the flag. These are great for finding answers that someone hid for you to find, some evidence that you're supposed to find in the contest, like testing your skills. We have malware samples, more images, and not just images, but data sets such as email data sets, documents, different file types that you can download for testing. We have registry samples and Windows event samples. All these are great third-party images and data sets to take a look at, because you might find something that specifically fits your need. We'll get into that shortly. Something about third-party images, and particularly I want to include in this random images. And by random images, I mean those kind that you find from garage sales or eBay, Craigslist, refurbished drives, that sort of thing. And that's where curiosity is the main goal, right? Because if you're curious of what someone's used hard drive has on it for remaining data, if they didn't wipe it at all or just formatted it, this I would say would be called unknown data. And the thing about unknown data is you don't know what it is, right, on it. So you may recover data that you don't want to really possess. It could be criminal evidence from child porn, personal identifiable information, or even national security secrets, things that you don't want to have that you can find and have been found on used hard drives. So on top of that, since you don't know what the data is on the drive, it's basically a phishing experiment to see what you can find. It's not going to be much of a software test. It's not going to be able really to test your theories of what happens with data moving across storage media. So like I said, it's mostly a phishing expedition that you're going to be wasting a lot of time for that. In addition to that, we have unknown activity. What I mean by unknown activity, you don't know what happened on that storage device, right? And you can't find out either. I mean, you can make assumptions based on running different forensic applications, interpreting the results, and just giving your opinion of what happened. The forensic tool says this happened on that drive, but since you didn't really see it happen, it's your assumption of your interpretation of the software, if the software works right. So you have unknown data and unknown activity. Those are kind of big negatives. The other one I mentioned was if it's not created for you, the third-party images. The odds of finding one image out of terabytes of images that has the operating system that you need to test with the user activity and specific type of data that you need to prove a theory or to learn or teach, you can spend days or weeks going through this list of terabytes of images and really never find something that you need. And what you end up doing is choosing a third-party image that sort of fits your needs, and if you use that, you're going to sort of be doing a decent job, but it's not going to be a good job. We also have data that's manipulated in images, and by that, what I mean is, let's take the Enron emails, for example. This is a great data set. It's a big data set of Enron PST files. Well, a lot of those emails were from employees who had nothing to do with the Enron case. So many of those email addresses have been scrubbed. Some attachments have been removed. Some emails have been scrubbed and removed. So what you have is some manipulated PST files, which may not matter to the test that you need them for, but practically it's not the original data, and you really don't know what happened, because not only did you have the user activity of sending and receiving emails, but you have analysts manipulating the data for privacy reasons, which I completely agree with, but it's just not the true data set. So that's what you have with the third-party data sets. Now back to the capture the flag challenges. These are actually pretty great for testing your skills. I wouldn't say these are great for, let's say, learning. You should actually have the skills first if you're going to do a capture the flag, especially a real-time, time-sensitive contest, because you're going to have to know what you're doing first before you can actually enter these contests to try to win. It's not much of a test for tools either. So you can write tools. Some of these require that you write your own tools. So you would hopefully have tests done elsewhere, because when you're testing an unknown data set, unknown activity, you're going to have a really low success rate on learning what you're doing there. So that brings us to build it yourself, and that's what this whole thing is about. And by building it yourself, I think this is really important skill to have, because you can choose the operating system that you need, the activity, you place it on there, and the data. You create the data or download it, get the data on the drive, however you need to have it on there, and that's going to be your test image, a true forensic test image, because you have known data and known activity. Now, the purpose of a forensic test image is what I just mentioned, is you can learn from it, you can test your theories, and you can teach others with it. And those are three big deals with, a legitimate forensic test image. And there's one good example, or a series of examples on YouTube with David Cohen's forensic lunch test kitchen. And he has a lot of recordings. He's done these live where he's actually testing, and where he's learning and we're learning, and he's also teaching, in effect, all in one. So what he's doing is basically you can see virtual machines here that he's using. He comes up with an assumption, a theory, and then he applies it to that virtual machine, and then he tests it. This is what I mean for having known data, because you can actually see him, Dave's entering something or deleting something or moving something, and then he actually sees what the artifacts are. So that's really the truest form of trying to find what's happening on a disk or any storage media for forensic artifacts. Which brings me back to the source, and just mentioned David Cohen's using virtual machines. You have a choice of a physical machine or a virtual machine. Obviously, the virtual machine is going to be much easier for creating your forensic test images for several reasons. One is because it's going to be faster to install the operating system. You can revert to snapshots. It's easier to manipulate and create images from one snapshot and keep those archival rather than creating a whole system on a physical machine. So let's take a quick look at how I do it for a virtual machine. I'm going to use VMware just as an example, and I'm going to quickly go through this. They're all basically the same, creating a virtual machine, but we're going to fly through, just accept the defaults for everything as we create the virtual machine. I'm going to speed it up a little bit just so we can bypass. This isn't how to create a virtual machine. This is mostly how I create a forensic image using a virtual machine. Some tips: I make it as small as possible because I'm going to image this thing later, so I want to make it a small virtual machine. So we'll go ahead and start it. We're going to install Windows 10 on this one. We just set up 64-bit, and I'm going to speed this up a little bit. And you can see this is a spreadsheet that I keep up. As I do things on the computer or the virtual machine, I just type it into my spreadsheet with the date and time and some kind of brief activity description. For example, installing Windows 10. Any passwords I'm creating, user accounts, I'll go ahead and I'll write that in my spreadsheet as well. So let's just speed up here. And now we're going to be booting into Windows. We're creating an account. And again, I just make sure everything's in my spreadsheet because that's the actual activity that's happening with the computer. This is user activity. It's not what's happening system activity, but things that I have created and things that I put on there. Starting programs. So you hear, I'm running through some Internet Explorer. I'm typing in URLs. I'm searching for different tools. Thunderbird email, for example. I'm installing VMware tools, which I highlighted in yellow because it's not really going to be your typical user activity. But you can see I'm logging out, restarting, logging back in, and everything that I see, I type into my spreadsheet. Here you have Internet Explorer opening up, and what I'm going to do, I'm downloading an email client because I'm going to use Thunderbird to do some email test. So I'll configure Thunderbird with an email address. After I install it, I'll do the same thing for, let's say, OpenOffice. Tools that I want to, or applications I want to use that I need to test, those are the ones specifically I'm going to put into the virtual machine. And again, the whole time I'm typing the activity. And this is really labor intensive because you click and then you type, and you click and you type, and you click and you type, and you have to make sure that you're adding everything. Here I'm creating Word, Notepad files, I'm deleting them to the recycle bin, empty the recycle bin, create another one, moving them to different folders, and I'm keeping track of the times that I'm doing all these because when I do the forensic analysis, the times should match what I actually did to the machine that I use. And if it didn't, something is going on with my forensic analysis or my interpretation or my tool. So regardless, I have the actual times that it happened, and I have the actual activity that happened. And I can do this with any type of activity, not just creating and deleting files. But as you can see with this one, I just did a bunch of files to create and delete and move, create folders. All these are documented, so when I do analysis, my timeline that my software creates should match my timeline that I created. Even I've changed the date, the clock date, and then I'll do some activity after the clock date. So my timeline, it should still match. But when I see that discrepancy in the times, and that gives me a hint of something happened with the clock. Obviously, I know it happened, but I can see what the artifacts are and verify my findings were correct. So anyway, that's just a really quick way of creating a forensic image and the user activity. What I usually do also is I have a workbook, and each workbook has one spreadsheet for one image. And if I have, let's say, 2 images that are in one case, for a test case, I will have both worksheets within one workbook. I'm going to talk about snapshots for a minute with VMware. You can look when you have, and you can use VirtualBox, obviously any virtual machine that software that you have or want to use. But with VMware, for one example, you can create snapshots. And what I do with the snapshot for here's one, for example, we have deletion test. So in this snapshot, I will do delete a file to the recycle bin, empty the recycle bin, create another file, put that in the recycle bin, wipe another file, and then I would document what I've done, and that image will have those files in that movement, and then I can test my software on that one snapshot. And I can go to I can create a new snapshot from that same virtual machine, and when that one I can do something different. I can have it focus on internet usage, type URLs, downloads, file sharing, that sort of thing, anything to do with the internet. So now I have 2 images, one using internet downloads, another one using deleted files. I can have another one using email, another one using steganography, whatever I want to focus on. I can have each snapshot image focus on one of those things, and I can use that same image for teaching. I can use it for testing and doing some different theories, and for software testing as well. I can use different tools to test on known data set and known activity. So what that means is one system, so I can create the one virtual machine, and I can create many images from that virtual machine from the snapshots. And when I say assuming the role of the bad guy, what that means is I'm going to create an image based on what I need. So from that one snapshot, or that one original virtual machine, I can have so many different types of images. Again, one for email, chat, deletion, file copying, file sharing, and they all come back to that original snapshot. So I don't have to recreate and rebuild a Windows 10 machine 10 times or 20 times. I can just create one, save a snapshot clean is usually what I have for the first one, and then I just modify that same machine from that clean, and I can revert back and then create a different one. Other thing is great with creating your own test machines is communication test. And where you're going to have different virtual machines communicate with each other using different applications, whether it be peer-to-peer, email, chat, and you can test theories that you have on real cases. You can create the same environment in a virtual machine, and then you can test your theories with what you found. So there's quite a few things you can do when you're building yourself, especially teaching is kind of a big deal if you have to have data sets, right, for teaching, because it's hard to teach hands-on if you don't have something. So one of the things you can do is have multiple suspects and multiple virtual machines, and they can communicate with each other, and they can do all the bad stuff, with files, deleting, encrypting, wiping, hiding them, sending them to each other. And you can have one complex crime or multiple crimes, different IP addresses, so you may have to change your IP address, maybe even go to public IP addresses. You can have geolocation and photos being part of the case, so you can take photos and have those with cloud storage and saved on a device. So you can have all those things put into, let's say, 3 drives or 5 drives or however many you want to have for a class, and then you can actually use that to teach case investigation, putting different devices together. You can have a single machine. Obviously, it's easier. Just have a single machine, and you can have one person doing all the stuff on there. But you can also include using the Tor browser. You can do a lot of tests with that. You can show students by the use of the Tor browser and what is found or not found on the machine. And then file movement or historical file movement. You can show the basics of what's the difference with the MAC times when you drag and drop a file versus moving it volume to volume, external devices, how you copy it, how you move it, and how does that affect the MAC times. So you can actually do that in a virtual environment. You can actually video record that virtual environment, and you can show that as a test, and students can actually learn by actually seeing that as well. So again, there's things we can talk about as far as testing malware. If you have claims of files were automatically downloaded, you can do some tests. MAC times with file copying I talked about, and computer clock and manipulation. If you have any allegations of the time being manipulated, you can actually do those tests. And specifically for teaching environments, when you throw in something like that where the students actually have to learn how to determine computer clock manipulation, you can actually have the original timeline of the actual data that happened, and they can actually interpret it through their software programs. Memory is another big one. With the memory, typically you're not going to know what's in memory, right? When you are imaging memory. But if you're doing on a real machine, that is, when you're doing the activity yourself on the machine, you pretty much know what's going to be in there. You know which password you logged into. You know what chats that you were sending. So when you image the memory from that virtual machine, you at least know what could be in it. So it is going to help you learn from memory, or learn how to dig into memory, what things you can find in it. Because if you don't know what could be found in the memory, you don't know what you're missing, or if you are missing anything. So again, practically anything that you want to learn, test, or teach, because you're planning the evidence, and then you find it, interpret the evidence, and then you can compare it to the actual data user activity that you created alongside. Teaching we talked about already, but basically one set of images, and I've used this every year, is I'll create, like over the summer, a set of images, and I use that for the entire course. And the same images you can use with the basics, right? So when you're teaching basic forensics in a basic course, that same image, although it does have basic things in there, you also have forensic advanced topics that you can have in there as well, and you can actually still use those images through the whole course and use it as a final analysis for the case report. So anyway, you can create the whole set of images you need prior to a course, and without having to redo it throughout the course or create more images during the course. I typically archive all mine. I complete my tests and I keep the image. I have more images than I'll ever know what to do with, just so many different operating systems. And there have been times that I've retested later with a software update. So when I'll get a software update, if it's a major update and I just want to, and I read, what was changed, what was updated, I will sometimes go back to a test that I've done prior with that software just to see if the update did in fact recover more perhaps, or interpret differently than it did the first time that I had tested. And it kind of gives me some reassurance of, yes, it works better and I actually found more. And it also kind of reaffirms that with the newer software, better updates, you actually can find some more, or have some different output, and you can test that, and it's easier for you to look to the future as far as when new updates come out. You can say, yes, I can't wait to test this on the last version against the last version I just did. There's some tips. These some big no-nos is never use real criminal evidence in teaching. I would also say probably not a good idea to use real criminal evidence for testing either. What I mean by that is if you have a case that you're doing, I don't know if it's a great idea that you're going to test your theories on real criminal evidence, because when I test theories, I want to keep the information, keep the image, and keep my report and my results. I'm not going to be able to do that with criminal evidence, especially if there's some stuff on there that I really don't want. I don't want to use real case data in classes or testing as well, because we're looking at non-disclosure agreements, PII, a bunch of things in there that you don't want to mix up with your personal files and personal test data. Different internet connections, I use that for teaching. If I'm looking at emailing between suspects machines, I may go to the library or a coffee shop or somewhere, and I'll log into public Wi-Fi just to send an email, just for different IP addresses, and just to show some different time zones, if I can do a time zone if I'm traveling as well. I'm sharing images. If you're looking at Windows, there may be some EULA end user license agreement concerns, so you don't want to be creating Windows images and sharing them with others if you're not taking precautions that you're not violating the EULA agreement. And I'm not going to get into that because it's hard to find the answer of how do you do that. I've read many different things of which files. I mean, it's not just the executable files. You're looking at DLL files that are protected under ULS. So there's a lot of files there, so something to be careful of and cognizant of. Keep your timeline up to date with user activity. That's probably the most important thing, because there's no way you can remember everything you've done to plant evidence on the drive. So keep your timeline up with the user activity. Now, one thing I've done once was I've recorded a dual screen where I recorded the activity as I was creating it on the virtual machine, and at the same time, and then I did a forensic analysis on it. And what I've done, I created a timeline, a visual timeline, and I screenshotted aspects of my activity with screenshot of the area space of that drive or the link file that was created, and you could actually see in real time as as I clicked a file to delete, you can see the screenshot in my forensic tool showing the deletion and the time matching. So that's one thing to do. It's a lot of effort, but it does help when you're teaching certain aspects of what exactly is happening at the time that somebody is actually using that computer. In case you want to refer back to the spreadsheet or the user activity spreadsheet, and this is just a quick example which I showed earlier. But one thing you can do with this as well, you can actually add another column for activity type. So you can add application type, you can add separated by time, or whatever thing you're teaching, for example. So you can have installation, you can have deletion, you can have all these different file types, activity. So let's just do one to show you what I'm talking about. We'll go ahead and we'll put type, and here we have installation. So we can put install. We can put application, if it's an application. And what you can do, you can actually sort by the different types of artifacts that you're looking for. So when you're giving, say, homework assignments or task in teaching, you can actually say, we're looking for application artifacts. And it makes it easier for you as the instructor or the professor, that you can easily sort by application types. So when you have the homework come in, it's easier for you to grade and faster for you to grade. And of course, it makes it easier to sort to see what's going on. And like I said, by having some sort of detail in the activity, it will help you be able to verify your tests are correct. And as much detail as you put in there is going to be up to you. Like I said, you can make it as minimal as possible or as detailed as possible, but this is just one example. All right, with that, I hope you got a couple good tips from there. And now the goal is to make yours.